Okay, guys, we're going to talk about complex numbers. A complex number was invented to take care of the problem. Remember when we talked about if I had the square root of a negative, we said there was no real solutions? Well, math people didn't like that, they couldn't solve that. So complex numbers is a way to solve problems when you have a square root of a negative number. Okay, so complex numbers are dealing with numbers with imaginary numbers in them. So imaginary numbers is denoted with the letter I. And the big part of this notes is that I equals the square root of -1. Okay, so the complex numbers is when you combine real numbers and imaginary numbers. So we write it as a plus bi, where a is a real number and bi is a imaginary number. Looking at some examples of the square root of -36. If I put that in my calculator, it's going to say error, no real solutions, because that negative, there's not a number that we can multiply by twice to get a -36. So if I look at this is really the square root of -1 times 36. Okay? And using that big information thing that we talked about last slide was -1 is just I, and then the square root of 36 is just 6. So my answer is just 6i. Okay. Now, if you look at the next one, the negative's on the outside. So I just know that that's going to be a negative. Square root of 9 is 3. Okay. And the last one, if I have the square root of a -50, well, that really is just the square root of -1 times the square root of 50. Okay. Now, I don't know what the square root of 50 is, so I can break that down into 25 and 2. And 25 is a pair of 5s. So I'm going to have a 5. And I know that this is negative. Anytime you see a negative out front, we can bring an I out. Okay? And then what do I have left behind? I have a 2 left behind. Now, we can add complex numbers. So when we're doing these, if you notice, these don't match. I have an 8 and a 50. So I actually have to break these down first, which that's going to be 4 and 2. 2 and 2, 25 and 2, and 5 and 5. Okay, there's my pair. Okay, so I'm actually going to have this as 2, and if the negative is on here, we need to get rid of that. So the way we get rid of it, we just put an I out front. Square root 2 plus, this is going to be 5i square root 2. Now see how that they're matching? They both have I square root 2's. Now I can combine those. They're kind of like terms. So I'm going to have 7i square root 2. Now if I look, looking at this bottom one, same thing. We don't have these matching, so we got to break these down. So 20 I can break down into 4 and 5, which is going to be 2's. This is my pair. So I'm going to have 2. That negative on the inside becomes our I, since we know that that's a -1 technically. Then we have the square root of 5. Over on this 45, we can break that down to 9 and 5. 9 is 3's. So I'm going to have -3. The negative's on the inside, so I'm going to have I, and then square root of 5. Now once you break it up like that, we can just subtract like normal. So 2 minus 3 is going to be a -1 I square root 5, and that's our answer right there. Now when we're adding complex numbers, just think of it kind of like terms. Okay, so if I look, I have real numbers. I have a -3 and a 7, and I'm adding those. So -3 plus 7 is 4. Okay, and then I have 4i plus -i, so that's going to give me a 3i. That's all that is right there. Now if I look at the bottom one, I can't combine them because I have square roots in there, but I can rewrite this. The square root of -4 is going to be 2i, okay, because the square root of 4 is 2, and a negative is going to become an I. Same thing with this 49, that's going to just be 7i. So let's rewrite what I have. I have 7 plus 2i plus -1 plus 7i. Now we can combine our like terms. So I have 7 plus a -1, which is going to give me 6. And then 2i plus 7i is going to give me 9i. And that is my final answer when I'm just combining those like terms. Now, subtracting is going to be similar, but there's one thing you really have to be careful of. It's that pesky subtraction. Subtraction is kind of a pain, so what I'm going to do is I'm going to change it to a addition. If I do that, anything behind it, I change those signs. So that's now become a positive 2, and this is going to become a negative 3i. Now it's just like we did. We have 3 plus a positive 2, so that's going to give me 5. Okay, and then I have 8i plus a negative 3i, which is going to give me a positive 5i, and there's my answer. Now we're going to do the same thing on the bottom as we did. We have to rewrite these with imaginary numbers since the square roots don't match. So I'm going to have 1 minus, this is just going to be 6i, minus 7 minus 5i. Now it looks just like the one we did on top. Remember, don't want to deal with that subtraction, so I'm going to change it to a positive, which will change the signs behind it. Okay, so a negative 7 and a positive 5i. So let's go ahead and add up our like terms. So I'm going to have a negative 6 with this 1 and this negative 7. Okay, then minus 6i plus 5i is going to give you a negative 1i, or just negative I. And that's my answer there. Now for this exit ticket, when do you need to use I to simplify radicals? Remember, the only time we'll use I is if we have a radical of a negative number. So in words, go ahead and jot that down and go ahead and get started on your practice problems.